All right, I'm back and now for something completely different. So, although I guess it's going to have some overlap a little bit with James's talk. Um, so I've been thinking about agents for a really long time, and in January I discovered that 2025 was the year of the agent. So all these things, some of that hype has died down. Now there's other things for people to grab their attention, but um, it relates to something that came up in Jonathan Cohen's talk this morning of right that there's lots of these ideas that our community, that his community, that we've been thinking about for a long time. And it feels like oftentimes that there's this new world out there that lacks awareness. I think he framed it slightly differently, but I'll be charitable and say awareness of some of the stuff that we've learned. So I've been thinking about this for several months, and then this talk is really about sort of this conceptual stuff that I've been doing, and the next talk is like how we're putting some of that conceptual stuff into practice in an actual new effort. So the first few slides here are just motherhood and apple pie, but just kind of like this is quickly how I look at the world. So what's an agent? I'm going to go back to Russell and Norvig and the Woolridge book, and so it's an entity that acts rationally in the world. We can talk about what rational is, but it's like consistent with your knowledge, more or less. There's all these properties that have been defined for what we mean by rational agency. This is all kind of like core 90s agent development stuff. And then alongside of that, the Russell and Norvig artificial intelligence book came out in the 90s, and it basically said, well, an agent is a combination of its architecture and its program. And the really important idea behind architecture from the point of view of Russell and Norvig to some extent is the architecture provides capability, but it also provides constraint. So just like I was talking about in the previous talk, right? If I don't have sensors to detect something, then I can't do anything with that. But if I've got sensors, then for certain kinds of phenomena, then I can do something with that and make decisions that influence my knowledge and my ability to make a certain class of rational decisions. So there's this whole class of agent architectures that have been developed. And really the agent architectures are essentially saying, well, there's stuff that recurs across different agent applications that I want to build. And so I can just build functionality for that. There's a whole class of architectures, the belief, desire, intention architectures, a whole bunch of instances of those with various flavors of that. Now, of course, we're mostly thinking about this from a cognitive architecture perspective. And I think about, for the purposes of this talk anyway, a cognitive architecture is kind of a notion of agency, a notion of how to achieve an architecture for an agent that's inspired by human cognition, right? And we could human cognition of the mind, like from the 70s and this kind of classic model here, or it could be more recent neuroscience stuff. And for the purposes of this talk, this goes back to some work that Randy Jones and I did, a long time ago now, 20 years ago now, is really we can just think about a cognitive architecture as an agent architecture that's inspired by human cognition. So I'm trying to kind of think about cognitive architectures and agent architectures as members of the same family. So now let's think about architectures for general intelligence. In the ideal case, an architecture for general intelligence would just kind of have these functions that were useful for all kinds of problems. And then we can think about that reformulation of the Russell and Norvig thing is just an architecture is a combination of its an agent is a combination of its architecture and its knowledge representation, knowledge in quotes there, because it doesn't have real knowledge, it just has knowledge representations. And then as John talked about earlier, and is mentioned this morning with respect to the common model, right? We know that there's these common patterns of functions that have been recurring. We see them in multiple architectures. I'm going to argue that we see a lot of the lower level details in agent architectures as well as cognitive architectures. So I want to introduce this idea of a cognitive design pattern. It's really drawn from the idea of a software design pattern, which is just a template of a common solution. And so for me, a cognitive design pattern is some kind of abstract description of some kind of function that happens in a cognitive system or an agent system and then it recurs. So it's not just it occurs in one system and it's a one-off, but we see that kind of pattern occurring in system after system after system. And the abstract part here that's going to be important and what we talk about is that I'm not talking about an implementation, and oftentimes it's not an algorithm. It's sort of a level above that, describing some kind of cognitive capability or cognitive function. So here's an example that might not jump off the page, but it'll be important for both this talk and maybe even the next talk, is that many architectures have this notion for certain classes of memory elements that you go through 3 stages to put something and take something out of memory, not 2. So in Soar, we can generate operator proposals. Operator proposals are kind of like what's called a desire in a BDI architecture. It's a candidate, something that I could consider doing. And then you make a decision in BDI that would be called a commitment to that thing. And then that becomes then something that you're actually trying to accomplish. And then on the other side of that, you don't want to make a commitment and then be blindly committed to it forever. So you need a kind of mechanism to say, I want to step back and not do that thing that I committed to do, even though I didn't accomplish it. And that's called reconsideration in the BDI world. And it turns out that, if we look at these things closely, the same thing that's going on in the BDI architecture is the same thing that's going on in Soar. They're using different algorithms, and reconsideration and BDI architectures are using all these decision theoretic calculations. What I did in my thesis was think about sort of an elaboration of assumption-based truth maintenance, and that's the way we can reconsider a certain kind of operator selection in Soar, operator decision in Soar. But at some level, they're the same kind of thing. So that's the notion of a cognitive design pattern, kind of diving a little bit more deeply. Here's another one, and this one's really hard to describe to this audience and not use Soar words, but this is what the decision loop looks like in a BDI architecture. You've got input that flows into the system from some environment. You do some kind of analysis, reasoning about that. That reasoning is generally called beliefs. We might call them elaborations in Soar. That generates some possible candidates for things to do, desires. You make a commitment. Here's the thing I'm going to try. That becomes an intention in the a knowledge representation in BDI. And then you start to take actions based on that intention. And of course, even saying that, you could immediately start doing the mapping for those of you who know Soar well. Well, that just looks like the Soar decision cycle with different words. And that's exactly right? So even though these architectures come out of very different intellectual traditions, even though there's lots of details that are different, at some level, they're the same. And that's kind of the core idea behind the cognitive design pattern to me, is trying to articulate what these common patterns are for various different reasons. And the reason that I really want to emphasize today, sorry, I was going to say, this slide just says, yeah, there's a bunch of design patterns. The reason I want to talk about these cognitive design patterns today is to think about, can they help us understand what's going on in that year of the agent with respect to LLM stuff that we talked about before. So I see there's kind of 3 questions that we could pursue, and we'll kind of talk about these for the rest of the talk. One is that we could look at things that are going on in the LLM world and put our cognitive design pattern frame on them and maybe understand them a little bit better, or relate them more to things that we've seen before. We might actually be able to use them predictively to be able to say there's certain kinds of gaps or issues or limitations that we might see or might be able to address because we more fully understand certain patterns of behavior from the cognitive world. And then it might also be that there's stuff that we definitely can learn from the patterns that we see being implemented in agentic LLMs. So let's look at some examples. So somebody mentioned earlier chain of thought. And chain of thought to me is just elaboration. It's essentially making things that are implicit explicit, right? So I'm going to go through this process of reasoning step by step, but when you look at actual chain of thought reasoning, what it actually looks like is something that often looks like elaboration, where you're saying, well, if that's true, then this must be true. And then if this is true, then that must be true. And so that looks a whole lot like elaboration. And it looks like this analysis process in BDI architectures. So to me, one of the things that really kicked off this whole agentic LLM world was React. And React was this, really great idea of saying, well, maybe I should separate reasoning, thinking internally, what's called thought in React, from taking action in the world. So those are just separate processes, and I can separate steps in my reasoning process. It splits these two things. It splits that process together, and it turns out that there's just a huge win with using a language model by telling it this is an internal reasoning step versus this is something that you're going to do in the world. So it's been very influential. It's incorporated in all the tools. So LangGraph and Crew AI, they've all got React patterns built into them. So what can we learn from looking at the cognitive design pattern, especially that decision loop that I talked about before, and thinking about React? Well, here's React in comparison to that BDI loop that I showed you before. And what jumps out at you when you look at this?
There's another step.
Yeah. So in React, there is no notion of commitment and intention unless it's implicit in thought. There is no explicit intention step. So it looks more like this two-stage commitment, sort of what you might see in traditional CS, as opposed to this three-stage commitment. So it's not making an explicit decision about what it's intending to. And there's no notion of reconsideration. So I'm going down the wrong path. I need to back up. And actually, Yao, the person that did this, his next paper wasn't really about tree of thought, which was about building this graph of possible paths. And this is where we can start to potentially make predictions, because we could say, well, what would happen if we added an explicit intention and reconsideration step in React? And we could sort of run through and look and see what the impact on the reasoning might be. So that's something that could be done. Maybe I'll do that. So here's a different pattern, which is an episodic memory. So we know a lot about episodic memory, touched on episodic memory this morning. Soar has an episodic memory that's really strongly informed by the Tolving model of episodic memory. And there's certain computational characteristics that we can associate with episodic memory. This notion of like really efficient storage is important, where there's a kind of compression process. The encoding specificity principle is really important, which says that I'm going to encode things and put them in memory. And then when I want to get them out, the closer my queue is to that thing I experienced in the past, the easier it is going to be able to pull that thing out, right? The other computational characteristics as well. So what about language models? So I'm going to mention generative agents. I do want to say that if we talk to the people that built generative agents, their paper never calls it an episodic memory. They don't claim that it's an episodic memory. But it turns out that if you look at all the papers that have come since this paper is cited thousands of times at this point, and people cite it as episodic memory in agents. So I just want to say that I'm imputing to it something that they don't claim it. And so just, I feel like that's important to say, because they could say, this is not episodic memory. So you've probably seen generative agents. This was the paper in which a bunch of individual LLMs interacted with each other in sort of a Sims kind of world, where they were, going to work each day, preparing breakfast for their kid to go to school, planning a party. And one of the key features of this system was that it automatically stored these memories about what happened. So they're very similar to episodic memory, all natural language traces. And then it could retrieve memories. And the retrieval was based on three factors. It was based on recency, importance, where the importance was it was sort of associated with the memory at the time of encoding, and then some kind of relevance, which was based on an embedding. And it also has this notion of a kind of reflection, where it's saying, well, the example in the paper is somebody worked in his lab all day, and then you say, oh, well, this person, lab worker, their work is important to them because they're dedicating their time to it. So I'm not going to go through this whole chart, but we can kind of look at all these features that people like Andy Nuxel put in their thesis and said, here's what goes into an episodic memory. And we can say, well, which one of these things is in generative agents and not? I just want to call out one thing for right now to say, well, the recording of memory in generative agents is sort of semi-automatic. Not going to go into the details right now, but there's a periodic process and it kind of decides what to save. It's not really saving everything the way that you would see saved in a Soar episodic memory. And then there's no episodic segmentation. It's just doing this every 100 turns, it saves things. And so the question would be like, in terms of retrieving things, could I retrieve things a little bit more reliably and usefully if I actually was using a more automated process with some kind of episodic segmentation, right? That's just a reasonable thing that we could explore next. All right. So the other thing I want to mention is I'm not going to go through the slide at all, but just that there is a huge amount of work that's being done in those communities that Jonathan mentioned this morning, saying this is inspired by human memory. This is inspired, human inspired. And that's really a lot of times the extent of what is mentioned in the paper. Like you go looking for what the human inspiration was, and that's the human, it was inspired by human cognition. That I'm not saying that is at all true for any specific one of these. I'm just saying that it's a pattern. So people are really, really searching for memories with language models. And they're looking to humans, kind of, but I think that we have insights from this community that we should be bringing to bear, or we could be bringing to bear. So, I sort of said, I claim that these things would help us. I showed you some examples from observe, decide, act, 3-stage commitment, episodic memory to say, yeah, these we're seeing those patterns and we can sort of say things about those patterns. Excuse me. I mentioned the notion that, well, there's not a real notion of reconsideration today in language models. Maybe episodic segmentation might be important. And then I don't have time today, but maybe somebody can ask me about reflection as something that might be, we could learn from language models. So for this talk, the nuggets are really, I think that these cognitive design patterns are pretty useful for understanding what's going on in agent and cognitive architectures. I also think it's useful for, at least for me, for understanding what's going on in LLM agents. It gives me a frame for kind of putting all this individual papers into a larger framework. And as I'm trying to convince you, it kind of leads to specific hypotheses that we could test, and potentially with our more complete understanding of a cognitive design pattern, improve certain proto-design patterns that are being explored today. As I mentioned, I'm a little frustrated that human inspired doesn't really have a lot of meaning in a lot of these papers. I'm also kind of frustrated, as was mentioned this morning, that there's not more visibility in the kind of stuff that we have done. And then I'm, certainly quite interested in anybody who thinks this is a good idea that would be interested in funding us to explore these ideas. All right. So I'll stop there. That was 17 minutes. And so I guess we 3 minutes for questions, and then we move on to the next talk after some initial reactions. Anybody?
Could you say something about reflection?
Oh, sure. Good job, Stephen. Whoops.
Hi, this is Mike Miller. Oh, go ahead. Sorry.
Yeah, so I just wanted to mention this notion of reflection. And one of the things that there's kind of two common patterns with reflection in language models. One is the pattern that's highlighted here. This actually comes from LangChain's documentation. And the pattern here is really, I do something and then immediately think about it. I think about this as almost like a super neurotic person, right? I just did something. Was that a really good thing to do? I just did something. Was that a really good thing to do? And there's another pattern called reflection, which was also actually developed at Northeastern. Where's Nate? And Yao was involved in that one too. And the idea behind reflection is like you try out some things, but you wait till you kind of get to the end, and then you sort of think about the whole. And that looks a whole lot like retrospection to me, but it's a little bit more error focused as opposed to what can I learn from this experience focused. So there are, I don't know exactly where this sort of mini reflection pattern would fit in a Soar or any kind of computational system with a kind of, this comes from the fact that you have a probabilistic system. And so you're kind of constantly having to re-guess, reevaluate, is the probabilistic thing I just did the thing I really wanted to do? But reflection and retrospection have a lot of overlap.
When I saw your title, I thought you were going in one direction and you sort of went in another, which is to say, if I talk about design patterns in software engineering world, we're talking about patterns of representation and software that you write, whereas the patterns here were all, at least as implemented in this community, within the architecture itself. So you were giving sort of compiler patterns versus software patterns. And I was just curious, since you've been thinking about it, do any of these exist a level up in terms of you've got the architecture there? What are patterns that you see in agent development, or is that just completely different problem space?
Yeah, that's interesting. I think about these things as somebody who spent 4 years in the guts of Soar as code you write, but yeah, I mean, I haven't thought about that enough to have probably anything too useful to say.
Hi, this is Mike Miller. May I speak?
Yes.
Okay. A couple points. Excellent talk, by the way. I think that LLMs are originally received success because they were associative memories. You know, an LLM is basically a very, very large hash table that has inputs and outputs. And you know, what we find now, I think that cognitive architectures were already on the right path, and the LLM group or the LLM paradigm is kind of stovepiping different things or kludging things together to approach cognitive architectures. I've looked at cognitive architectures for the past 15 years. I wrote a book called Building Minds with Patterns. You know, it's about design patterns for cognitive architectures. And I think we're already on the right path, and integrating some of the features of LLMs is a good idea. I think the idea of looking and isolating the design patterns is a good idea. And I think that mainly we just have to look at in the book, I looked at 25 different cognitive architectures and isolated design patterns, including Soar. So Soar was one of the systems I reviewed. And I think that including I think that we shouldn't go backwards, but we should go forwards. And so LLMs represent an associative memory. And probably the real question is, how do we integrate associative memories into the current architectures that we have? So we have a space for working memory, for long-term, short-term memory, procedural memory, but maybe there should be a carve out for associative memories and see how that plays into the overall cognitive architecture. That's just my thought.
Great, thank you. I think there'll be a slide in this talk that this next talk that you'll really like that talks about integration. But yeah, I do think that there's, yeah, I mean, part of what I was getting at is that the connections are two-way, and that there's stuff that we can learn from them, and that ideally there would be stuff that they could learn from us. And so and exactly which parts of cognition are best modeled by, you know, a symbolic processor versus an associative memory, right? I think that's kind of familiar terrain for stuff that we've been thinking about a long time.